क्या आप IAS की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेनड्राइव कोर्स के साथ आप IAS की तैयारी कर सकते हैं। आज ही विजिट करें studyIQ.com।
Hello everyone, welcome to StudyIQ. So we will continue our discussion on combination. So last lecture what we were discussing is we were actually discussing about total selection, right? Total selection means any selection. So we have taken care of all the possible selections, right? If we are given 4 items, we have taken care of selection of 1 item, 2 item, 3 item, 4 item or 0 item. And what we have seen is in case of n distinct items, total selection is given by 2 raised to n. Okay, so 2 raised to n is the total selection, and we have seen enough applications of this. I told you number of subsets of a given set is application of this only, 2 raised to n. Okay, again I told you zero selection is also involved in this. So in case if the question is talking about at least one, that means if there is a constraint that at least one should be selected, there is no case that you cannot select anything. Okay, so in that case you need to remove that zero selection, so it is 2 raised to n minus 1. And this case we have seen application in case of subsets. Okay, so number of subsets are understood by using this case. We have seen the application in terms of number of different sums you can make with some coins which are given. Okay, so we have seen this. Then in the next case that is not that important, identical items, we have seen total selection is given as n plus 1. Okay, and if zero selection is to be avoided, then it is n. So that's what we discussed in the previous lecture, and that's where we stopped. Okay, so let's look at some example. Okay, so if I give you a question that there are 20 items. Okay, so there are 20 items, so or 20 books, you take it as 20 books. You have 7 maths book. Okay, then you have 5 physics book. Okay, you have 4 chemistry book. Okay, so 12, 4, 16. Then you have let's say 3 history book. Okay, 3 history book. Now you have 1 geography book. Okay, so these are the different types of books that you have. What I need is I need to make a collection of book. Okay, so this is the available option. That means you are going to a library, so in the shelf you can see this many books. That's what you need to understand. Okay, now let me frame the question. So I need to make collection of some books from this. Okay, so the collection is only possible from this books. Now the condition is how many different collections you can make. Okay, how many different collections you can make means what are the different possible selections or what are the different possible combinations. Now what is the condition? By selecting 0 or more. Okay, by selecting 0 or more, what is the next condition? By selecting at least one. By selecting at least one from each. By selecting at least one from each category. Okay, so by selecting 0 or more means if I don't wish maths, I don't want to select maths. I hope you understood. That is the first case. So when it comes to the second case, even though I don't wish to have maths, I am telling I need to include this particular selection. At least one should be selected. Okay, so these are the 2 different cases. Now let's try to understand. So one more point which I need to tell you is here within this particular category the books are different. All the books are different. That means all the 20 books are different. I'll come to a different case after this. At that time I tell you within maths all maths are same, within physics all physics are same, within chemistry all are same, within geography and history all are same. But here even within maths also all are different. So that means all 20 are different. I hope you understood. All 20 are different, maths different, physics different, all are different. In that case, it is nothing but 2 raised to n application. Okay, so distinct items, so 2 raised to n application. So 0 or more, selection of 0 or more means you can see here, selection of 0 or more means this is 2 raised to 7. Right, that is 2 raised to n, so n is 7, so total 20 is there, so obviously this is nothing but 2 raised to 20. 0 or more means 2 raised to 20. So what does that mean? 2 raised to 20 means there is a problem here. How are you getting this 2 raised to 20? Maths can be done in 2 raised to 7. Okay, then physics can be done in 2 raised to 5, then 2 raised to 4, then 2 raised to 3, then 2 raised to 1. So totally 2 raised to 20. That's how you are getting 2 raised to 20. But in all these cases, if you are taking 2 raised to 7 and 2 raised to 5, 2 raised to 4, 2 raised to 3, 2 raised to 1, okay, See, 2 raised to 1 means 2. What is that 2? I have only one geography book. So I may select or I may deselect. Okay, selection or deselection. I may select or I will not select. These are the two possibilities. So what will happen? Now here, this 2 raised to 7, this 2 raised to 5, 2 raised to 4, 2 raised to 3 involves a zero selection possibility also. Okay, so I'm talking about 0 or more. I'm applying the formula 0 or more, that is 2 raised to n. So this involves zero selection also. So there can be a possibility that I'm not selecting anything from maths, physics, chemistry, history and geography. There can be a possibility. So that possibility should not be there, because in the question what is given is you should have some books, or at least one book should be there. You need to have a collection of book, right? If you're not selecting anything, there is a liberty. 0 or more means from a particular category, if you don't want to select, but you cannot exercise that in all the cases. You need to get some collection. So there is a possibility that all can be 0. You remove that means -1. So your answer is 2 raised to 20 -1. How you're getting is like this. Okay, now what about at least one from each case? Then that is not a problem. At least one means you can go for this thing. At least one from 7. That how can you do that? 2 raised to 7 -1. Similarly, 2 raised to 5 -1. Okay, like that you can complete and you will get that answer. You will not face any problem. Now, again in this same case itself, what I'm going to tell you is within this maths, all the maths are same. That means by the same author, by the same subject or same page number, same content and everything is same. Then these are identical items. Okay, so in this case, again, this is the two question. I need to make collection by selecting 0 or more, or by selecting at least one. There are two cases. So what if I'm going to select 0 or more? What is going to happen? 0 or more means total selection, that is n. N here means 7, then into 5, into 4, into 3, into 1. Sorry, total selection is not n plus 1, right? So if it is n plus 1, so I need to write 8. Okay, so 8 ways I can select 0 or more. Okay, so 8 ways. Then from this I have 6 ways. Okay, here I have 5 ways, that is again n plus 1. Here I have 3 ways. Here I have 2 ways. I either select or not select. Okay, so I need to multiply. Now, the point which I need to stress on here is this 8 ways and 6 ways, 5 ways include, there is a possibility of 0 selection. So it can come in all cases, then you will not have any collection. So we need to remove that particular possibility. That is your answer. Now, when it comes to at least one, then what is your answer? Then just write like this, n minus n. Here n plus 1, at least 1 means n. So 7 into 5 into 4 into 3 into 1, and that's your answer in case of at least one. I hope this is clear for all of you. Now, one more application of this you can see in case of finding number of divisors. Okay, so number of divisors or number of factors. Okay, so number of factors, if you remember, we have discussed this in the previous discussion. So if you can write a number a, okay, in terms of or let's say number p in terms of a raised to m and b raised to n, where a and b are prime factors or prime numbers, then number of factors is given as m plus 1 into n plus 1. I hope you remember this. Okay, now here let me tell you how you are getting this concept or formula. There is no point in talking about the formula, but the logic I tell you. Okay, let's take one example. Let's take this number n is equal to 8400. There we have solved 216 or 21600 or something like that. Okay, so 8400. Now what we need is we need to find the divisors or we need to find the factors. Okay, so what you can do first, you need to prime factorize it. So obviously you can write it as 81, you can write as 21 into 4. Okay, so 21 into 4 into 100. 100 means I can write it as 25 into 4. Okay, now 21 anyway you will write as 7 into 3. 4 and 4, that is 16, that you will write as 2 raised to 4. So 2 raised to 4 into 25 is 5 square. In between there is a 3, then 5 square into 7. Okay, so this is the prime factorization of 8400. So 2 raised to 4, that means 4 2's are there, then 1 3, 2 5's and 1 7. So this is what there in the factors. When you are prime factorizing, this is what you understood. Okay, now what do you mean by divisor? Divisor means this number must be divided. Okay, so I can tell you 100 is a divisor very easily, right? Why 100 is a divisor? Because 100 divide this number. Now how you are getting this 100? You combine any one from this, like this 25, then combine some 2 square. So you get what 100. So basically divisor means I am looking for some combination from this. You can see here there are 4 2's. Okay, there are 4 2's and 1 3. Okay, and 2 5's and 1 7. Make different combinations. Okay, so make different combinations and you will get different divisors. So how many such combinations are possible? So you can see here 4 2s are there, and you know clearly 2s are identical. So if it is identical means total selection. Total selection means n, right? If there are n items, total selection is n plus 1. Right? If the n items are there, total selection is n plus 1, at least one is n. Here, there is a possibility that I can go for 2 raised to 0 also, because if I am not selecting anything from 2, that is not a problem. I can make this combination. Okay, I can make this combination. 21 is a factor by selecting 3 and 7 without selecting anything from 2 and 5. So 0 selection is possible in this case. Okay, so what I can do here, n plus 1 is what I need to apply here. So when you apply n plus 1, this becomes 5. So 4 2s are there. Okay, so that's why when you take n plus 1, it becomes 5. How many 3s are there? You have 2 3s are there. Okay, so when you take n plus 1, there is 1 3, so it become 2. 2 5 is there. So when you take n plus 1, that become 3. 1 7 is there. So when you take n plus 1, that becomes 2. So when you multiply, you will get the number of factors. So that is what you actually got from the formula a raised to m and b raised to n. If you can write in that way, m plus 1 into n plus 1. Just I hope you understood why you are getting that m plus 1, n plus 1. Just look at the power. Okay, so here p you can write as a raised to m, b raised to n. What does that mean? There are m times a and n times b. That means a are identical, m times a is there, and b is also identical n times. So number of ways of selecting 0 or more from n identical items, n plus 1. Here it is m plus 1 and here it is n plus 1. I hope you understood how you are getting this formula. It is nothing but application of combination or selection. Okay, so hope this is clear. Now the next possible question will be number of odd divisors. Okay, so odd divisors. Again, let's take the same number 8400. So we know this is 2 raised to 4 into 3 into 5 square into 7, right? Number of odd divisors means I should not take this portion. Okay, I should not bring 2 in any way. So without bringing 2, how many ways you can select? That is what they are actually asking for. So just ignore this part, completely ignore it. Okay, then what you can do, then it becomes 3 into 5 square into 7. So it's nothing but selection of total selection of this, because I need to see all the possible combination. Total selection of there is only 1 3. So how many ways I can select? 2 ways. Either I select or I won't select. There are 2 5s, so n plus 1, that becomes 3. There are 1 7, so again I select or deselect. So this is your answer. So how many odd factors will be there? 12 odd factors will be there. Okay, so if I ask you how many even factors will be there, you know the total number of factors, you just got the odd factors and you can easily calculate the even factors. And calculating method for, then if you remember how to calculate the even factors, the shortcut that I have discussed earlier, right? So what was that shortcut? This portion just write like this, the power just drop it like this. So take a minute gap or leave from combination discussion. This is a shortcut that I have discussed at that time. So the context is entirely different. Okay, so that is one point which I need to stress on here. That's why in fact I thought of not discussing this, but since I have discussed about odd factor, as per concept you can just take it as total factor and odd factor, then subtract it. But otherwise shortcut is like this. Just drop this 4 like that without doing anything. Then others, as usual, you apply the formula that you have learned. So 3 raised to 1 become 2, 5 raised to 2 become 3, 7 raised to 1 become 2 again. Okay, so here you can see this is 12 into 4, 48. So total 60 factors are there. This is 48 even and 12 odd factors are there. I hope you understood this. Now sometimes you will see proper divisors. You just need to know this concept of proper divisor. So what do you mean by proper divisor? See, you take any number. Okay, let's take this 8400 itself. We have seen that there are 60 factors. Okay, there are 60 factors. So out of this, how many proper divisors are there? See, this number, there are 2 fixed factors. One is always a factor of any number, and that number itself is a factor, 8400. So avoid these 2 factors. You get proper factors. So proper factor is just a different word which is used to check the concept itself. So 60 minus 2, you get 58. That is the same in all case. You just need to find the number of factors. So they are actually checking you whether you know how to find the number of factors. That's it. And at the same time, you also need to know the concept of proper factor. Then you can get the answer. Just subtract 2. You need to find ultimately number of factors. Subtract 2, you'll get the total proper factors. Okay. The next concept is sum of factors. Okay, we have discussed this in detail, what you need to do is, okay, let's take one example, 8 into 9, or let's take this number 72, which you will write as 8 into 9, which ultimately you will write as 2 cube into 3 square. Okay, so if I ask you how many divisors are there or how many factors are there, it is nothing but number of ways in which you can select from this, or the total selection or total combination is what I am asking. So since there are 3 2's, I'll write it as 4 because n plus 1. Then there are 2 3's, I'll write it as 3 because n plus 1. So total factors, if you ask me, that is 12. But what I need sum of those 12 factors. So I hope you understood the concept here. What I'm asking is, if you take this particular number 12, if you ask me what are the factors, 1 is a factor, 12 is a factor, 2 is a factor, 6 is a factor, 3 is a factor, 4 is a factor. So there are 6 factors. What I'm asking you is to find the sum, 1 plus 12 plus 2 plus 6 plus 3 plus 4. And that's exactly what I asked you here also. So how will you find it? Now, can you tell me what are the factors here? The factors or the divisors, if you ask me, 1 will always be a divisor, then that number, that is 72, that is nothing but 2 cube into 3 square. Okay, so, okay, 1 means what? This is nothing but 2 raised to 0. See, this 2 raised to 3 means 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. 2 raised to 0 means I am not selecting anything. That is one way. That's why I am adding this 4 here. I hope you understood, right? So 1 is a factor. Then I select 2. That is a factor. You can go for 3. That is a factor. Then 2 into 3, if you take 1, 2 and 1, 3, that is a factor. Then if you decide to take 2 square, that is a factor, 2 times 2. You can take 3 square also, that is a factor. Then what you can do is, you can take like this 2 into 3 square, or you can take 2 square into 3. Okay, then you can take 2 square into 3 square, then 2 cube into 3. Okay, then what is left out? 2 cube is left out. 2 cube is one selection. Then 2 cube into 3 square. So these are the total divisors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have total 12 divisors. I'm asking you to find the sum of this. Don't you think this is a difficult task? But what is the concept actually? How you're going to do is, sum is given as, see, you already know the shortcut. Here my objective is not to discuss the shortcut. My objective is to discuss the concept here. How you got the shortcut you understood in the previous lecture. Here also towards the end I'll tell you that. Okay. So you can see here 1 plus 2 plus 2 square plus 2 cube into 1 plus 3 plus 3 square. What is this one? This one is nothing but 2 raised to 0. What is this 2? This is nothing but 2 raised to 1 only. This one is also 3 raised to 0 and this is 3 raised to 1. Okay, so basically when you multiply all these, when you do this, you will get the sum. And you know the shortcut. Now, if you need to see how can you do this, otherwise there is another concept which I have discussed in GP, if you remember, sum of GP, right? Now, you see here, you observe here, don't you think this is a particular series? Okay, you can see here this is a GP with a common difference 2. You can see here 1 into 2, 2. 2 into 2, 2 square. 2 square into 2, that is 2 cube. So this is a GP with common difference 2. Okay. So, and what I'm asking you to find is, I'm asking you to find the sum of GP. You know the formula, that is 2 raised to 4 minus 1 divided by 2 minus 1. Okay, you know the formula A, R raised to n minus 1 by R minus 1. Here A is 1. Okay, what is R? R is 2, so 2 raised to 4, because 4 terms are there, minus 1 divided by 2 minus 1. Okay, similarly, here you can see here, what is common ratio here? 1, 3, 3 square, so common ratio is 3. First term is anyway 1, because in all these cases, the first term will be 1 only, because you are taking that 3 raised to 0 or 2 raised to 0, or next prime number, if it is 5, 5 raised to 0. So, and that's how you're going to generalize. I tell you how you're going to generalize also. So, you'll write it as 3 square minus 1 by 3 minus 1. Okay, so this is another GP, this is first GP. So you can find the answer like this. Or what is the formula? If you have a number P, you want to find the number of factors. First you need to write A raised to M, B raised to N. You know the number of factors, that is M plus 1 into N plus 1. Sum of factors. Sum of those factors, what you need to do is, you need to write like this, A minus 1, A minus 1. What is A? A is the first prime factor. Here you can see 2. So you can see 2 minus 1, 2 minus 1. That's what A minus 1, A minus 1. Okay. Then you need to write B minus 1 divided by B minus 1. What is B? That is the second prime factor. You can see here 3 minus 1, 3 minus 1. I tell you about the power. Power is, see, if you have M here, you need to write M plus 1. If you have N here, you need to write N plus 1. That's it. So you get the sum. You don't want to write all these things and think all these things. The moment you see the number, prime factorize like this, write like this, you get the sum. Sometimes you will get a question on product also. So the product, I tell you directly, product of the factors of the number is that number raised to the number of factors by 2. This is the product. Now if you want to name it as a formula or something, you need to write like this: product is equal to number. Okay, so number you will write like this: a raised to m, b raised to n, raised to number of factors. That's what I told you. You will write it as m plus 1 into n plus 1 divided by 2. But what is this a raised to m, b raised to n? That is your number. What is this m plus 1, n plus 1? That is the number of factors divided by 2. So directly you can write like this. Okay, so what we understood is the concept of divisors or concept of factors. Then we saw how to find the odd factor. I told you how to find the even factor, the shortcut. Then we have seen sum of factor and the product of factor. Okay, so all these are actually connected to this particular topic combination. So I hope what all things we have learned in the chapter of factors, you understood the logic by using this concept of combination here. Now, next what we need to do is we need to see selection and arrangement together. Okay, so we have done with selection in this areas. In the beginning we started with arrangement. So we done with arrangement separately, we done with selection, or you done with permutation, then we done with combination. Now what we are going to do, we are going to do both of them together. Okay, so what is permutation? Permutation is an arrangement. Permutation is arrangement. Okay, so one permutation means one arrangement. Arrangement or permutation of n distinct item in taken R at a time, we know that is NPR. Selection from n items, that is NCR. What is the relation between these two is what we need to find out now. Okay, so you all know NCR is equal to NPR divided by R factorial, right? This is the relation. Or NPR is equal to NCR into R factorial. So this is arrangement. Arrangement is equal to first you select, then arrange among themselves. Okay, so how it is coming? We all know the formula. NCR is equal to N factorial divided by N minus R factorial into R factorial. NPR is equal to N factorial divided by N minus R factorial. So clearly you can see this part is common. So you can see here, you can replace NCR here with NPR. So NCR is equal to NPR divided by R factorial, and that's what we have written here, and from there you can write like this also. So I hope this concept is clear. We are going to discuss more of this relation and both permutation combination in the next sessions. Okay, so we'll be taking selection and arrangement together and we'll be discussing more.
क्या आप आईएएस की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेनड्राइव कोर्स के साथ आप आईएएस की तैयारी कर सकते हैं। आज ही विजिट करें StudyIQ.com। क्या आप आईएएस की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेनड्राइव कोर्स के साथ आप आईएएस की तैयारी कर सकते हैं। आज ही विजिट करें StudyIQ.com।